Okay, so we will continue with the LookDev. One thing I did in between was to create a little volume box, just to test just so because it looks better with the volume, and the way we can do this is so this is the LookDev. Let's give this a name again, and just create a geometry network and just do an object merge and bring the building itself from here, and then just hook up a box which is going to generate a box based on the bounding box, and I'm just making it a little bit bigger, and then I just convert it to volume with a VDB from polygons, and then I have two networks here. It's basically I'm just creating a random, like a volume with a ramp. So if I take the position and then get the relative bounding box, that's a vector, so vector to vector. So I'm just interested in the y-axis, and then I connect the second vector, which is the y, into a ramp, and then I have a multiplier just so it's this is probably, we could expose that out anyway, and then I have two noises here using the position. So these are the values, and then I have another one, some other values, and then I just multiply one with another one, and finally I have another ramp, which then I have a final multiplier. So basically when I run this, it kind of just multiplies the density. It's fairly simple. You guys can open up the file and have a look as well. And then I have another one just based on the y-axis, literally just the fall off of the bounding box, and then I just VDB combine them using maximum, and that's what I render to test the shade, the lighting, etc. a little bit, which gives a bit more final result of what we are aiming for. The next thing we're gonna do though is to create the advertisement network. So for that we're gonna go, it's gonna be in the environment section. Well, it's gonna be in the building section. So I should never turn that on. So then under the buildings, create an ads network. So we're gonna dive inside. So this we're gonna use a little bit of a Python. So so what I did was I wrote a little Python script that searches for a folder. I'm gonna use another one because our advertisements, we want them to be realistic images, obviously. Why am I not getting too many of them all of a sudden? So I just googled some images like sci-fi ads, etc., and I create a folder with all these images that I downloaded from the internet. And they all have different sizes and different resolutions, etc. And then I renamed them like this. So I have 32 of them. I also converted them to RAT in case I want to use, I think I'm using only 10 of them, in case I want to do a little mantra. I also converted them, 30 of these, to RTX bin, which is the Redshift's own texture format. And then, in case you guys are using Linux, I have a little code here. I think this was the one. Yeah, so this just, if you run this, it's a little Python. If you run this command in a Python, in Python in a folder, it will just, I think, resize everything, and then it will rename the files as well. So, so how can we actually? I'm going to now actually copy this folder into the folder that you will find in your folder. Where is my file? it goes in here, right? It goes under text, adds JPEG. Okay, so what are we gonna do now? I'm gonna open the Python shell here, and I'm gonna create a little Python SOAP, and we're gonna write a few codes of Python here. So I want to be able to check system settings, so that's gonna be import os.path, and then I'm gonna copy paste this actually, but we're gonna update this path now with the correct one. Not here, not here. Where did I close it? Oh, no, it's here. Okay, so you're gonna update this with yours. There are slight variations from Houdini to adds /JPEG from Windows to Linux, but I'm not covering this, but there is a workaround for this anyway that I'll show as well. So basically now I have a variable, string variable, that points to the JPEG folder. So this tool now is going to count how many files there are inside this folder. Just the text count will return a len attribute, and then it's gonna create a geo attribute and then it's going to print the count. So as you can see now here we have a detail attribute 32. It's also printing that there are 32 textures in this folder. So then I want to create a point at the world origin. I'm gonna hide this, and then I want to put a copy 2 points. Oh, not copy 2 points, sorry, just copy and transform, copy stamp, no, just copy, no, not this one, just copy and transform, my bad, sorry, copy and transform. So I want to duplicate this 32 times. I could have done this here too, but it's a bit easier. So I know that there's 32, so we can fetch this. I mean, from our previous notes, we can automatically use a detail attribute towards the Python. So let's call this check folder. And then actually let's link that up. Maybe it's better. So it's a detail check folder, close comma. So it gives us the name. The second after the comma we need to put an attribute that is a string, so it's a text max, and then first one, so that should return 32. No, it returned 1. Maybe it's a different name. Text max, yeah, it's our it's supposed to be like this. Okay, so automatically now we created 32 points. It's coming from how many files we have. So then I'm gonna create an attribute wrangle, and I'm going to create textures. So what I'm doing here is I'm gonna paste this. I'm creating a point attribute called add ID, and then I'm going to create a string attribute called texture name sprintf. Okay, so we need to update this path obviously with what we have here, because that's my other folder. So all the way here. Yeah, so now it created a string attribute called, that's pointing to our textures basically. And then I want to use a special function called text import. And text import does something very cool. It actually returns the resolution of, if I hide these, res. So I'm saying like use the text import function using the texture name and fetch the resolution as a vector. So then it gives me the X and Z. So basically it gives me the resolution of the textures. So I can use, so basically I can use this to create boxes that are grids that are actually the size of the texture, so I don't have to reformat them or just go one by one so they don't look stretched. So let's call this get resolution. And but remember, because we are using get textures, because we are using Redshift or even Mantra, we shouldn't be using JPEGs. We should be using either RAD files or if it's Arnold, there's TX. If it's RenderMan, there's text, so on and so forth. So let's, because I already have converted them, which I already copied these in your folders. So I'm just gonna replace these here. Add RS text. So if I go here, I already have that folder here, RS text. So I already converted them. These are Redshift's inbuilt functions. You can follow these from the manual. So now what I want is to create a little grid, and then I wanna, so there's a grid. This is a default grid. It has 2 rows. So if I focus here, it's on X, Y plane, and then I put a transform. Just basically, probably these are not like really necessary. I could have really actually scaled it properly in the grid. And then I want to copy this, another one, and then I'm gonna say advert, and this one is going to have, it's gonna be fetching some information from the copy from the copy points we're gonna make. Just create a UV, and UV is gonna be on x-axis, and then we're gonna divide this. I'm gonna divide this with Bricker at 0.15, 0.15, okay. And then what I want is to basically copy these points to here, but these are not actually big enough. We need to make them smaller, I believe. Let me see here. So let's create a, that's gonna do. Okay, so let's do a copy to points. Copy to points. We're gonna copy this shape on these points. So right now they're gonna overlap obviously quite a lot because we haven't defined the size yet. But what we want is to create a for each network for each point, and this guy goes in here, and then put a null here. We're gonna call this info, and then copy to points. This goes here, this goes there, and it's gonna basically kind of like copy it 32 times. But what we need to do then here also attribute promote, and we're gonna copy the texture name from point to primitive, change the promotion method to first match, and now here we should have our resolution information, which this guy is gonna fetch from. So in order to get that information, we're gonna type this little expression called point. Again, to fetch the point data, we use the point expression, info, and then first point, the name of the attribute, and if it's a vector, is it XYZ or not, and then times 0.02, and then just copy this, and then type here. Now we want, because remember it was a vector, so we're gonna get the Y. So if I go like this now, actually let's go here maybe. now it's taking a time because we want equal size geometry, and then we have it's gonna get bigger for some stuff. So this one, I think we're getting some overlaps, which we should probably make. Maybe this was it, the actual size. This is 1:1. Oh yeah, sorry, this needs to be 1:1. Okay, so the way I was building my textures was kind of like this, but now we have the UV as well. So actually, I think I create the UV down. Okay, so then now we can set our material network. So if we look here, I think I was creating my UVs somewhere else, to be fair, but I'm not sure. I had to investigate because this doesn't feel exactly correct, because I feel like I should be creating my UV here instead, possibly, because this feels more accurate. Like this. Yeah, probably that's the way to go, to be fair. And then we're gonna create a material network. Oh, but now it has to calculate all the advertisements. So it's basically creating a unique advertisement per texture resolution, so we don't get stretchy textures, etc. And we're gonna go here, so there should be 32 of them now, but I think we should also was I packing these? I think I packed them somewhere. Yeah, I packed them. We should pack it down here so we can split them again after. And one more thing, we should probably turn around, and then I think where's the pack? So we get the UV, we should pack this, and in here we should probably promote add ID and texture name, so we can go here and promote it to here. So now it's packed. It is packed. This is wrong. This should be 1 point there. Let's look again. Yes. So there's the so we copied the ID, and now we have a path to the texture name as well. We do not need path attributes. So let it cook. Okay, now we want to also put a blast here, because we need to bake these out. Put a $F here, so that's going to return the frame number, and then I go delete. So it's always per frame, it's going to always keep a different texture. Okay, so now here we're gonna put a path to our texture, which I already built. Obviously we can look inside after. This one is called, where's my attributes? It's called Redshift adds emission, this guy. So let's go to shop network. Oh, it's gonna load everything now. We should kill this because changing the frame changes the building, remember. Let's go to shop network, space this. So let's have a look inside. I have a texture sampler here, which is pointing to a file name, which is this. It's empty because it's going to be inheriting the the point attribute, and then I just have like a little offset here that I hook up the frame, divide by F, so I want a little noise to move over frame range, and I'm multiplying that with emission color, and the output of the texture is connected to diffuse color, overall color, and opacity color. Okay, and then I am going to, this has some settings that needs to be done right, obviously, which means on the in order for Redshift to understand the textures, but that's going to be in the I think in the render version, so we can keep that for now. Let's point it to our shader. It's gonna be material here, but then we want, remember, because we have custom textures, we want to do a little override, and our attribute name is called text path. The parameter name, this is matching, where is it, this is matching this guy, and then let's go back, and then I want to overwrite the string value, which is the texture, right? So then it is linked to prims, so this is the primitives. So let's go, if we visualize this guy, and then select this one, so it's pointing to primitives, so it's the primitive, and then for each and one, so it's looking up here, and then it says for primitive, each primitive number fetch the texture name, so it's going to update the texture to be used for each one of these advertisements. And the next thing I want is I want to create a Redshift proxy. So this is kind of like a packed object, Redshift proxy output. I'm going to put this here, and I need to find out the address that I was using. So it's going to go up here to subpath, and I am using this address, and it's going to ditch any attribute, for example, it doesn't use. It's going to create the folders, etc. And then I know that I have 32 of these, so I'm going to change the frame range to 0 to 33. 0 to 33. Redshift, I think this is default. There's nothing else. So then let's say adds baked, rs baked. Okay, so let's select this guy and then render to disk. Now it's gonna just ditch everything that doesn't if the point number, the prim number doesn't match the frame number, it's gonna ditch them out. So if we go into the folder now, we have our baked proxies, which means that when we hit render for Redshift, it doesn't have to do any kind of conversion. It's just gonna replace those objects with these ones. Okay, so then we can now go outside. We bake those. So we will continue from where we left off. We are going to now spread these little emissive advertisements that we did around our building, so they look a bit more interesting, and so they can receive some reflections from these luminous advertisements as well. So the last thing we did was that we baked out our original Redshift archives after we created our images, after we download our images from the internet. So then now what I need to do is to basically go back into our building test. So remember, we split our advertisement sections here, and now we are basically going to replace these with a few random of those. So how many do we have here? If I unpack this layer, I'm gonna have 7 primitives, which means I can replace randomly each one of these using their centroid and normal with our 7 advertisement billboards. So let's do that. Let's move this guy here on the right, and let's drop in an object merge. So I want to bring in not necessarily, but in order for us to visualize, maybe it's a good idea also. So let's bring in our advertisements here, all unique packed versions. It is gonna be from here, material 1, This is only for visualization, so we can't bring this guy here. Actually, I think what we can do is we can also probably, because we're using Redshift, so we can't really display everything very easily. I think what we can do is we can create a little neat trick here. We have, as you know, we already have our shape that we're copying on the points, but we can also create a group here, and then because we pack our, out of this sphere, we create our object here, right? And then we copy these onto our points, which is, where is our this is our shape. So then I guess we can also put a group under the copy the points, and then we call this to render, and then just select that name and then replace the group name as well. And then I guess we can do another just duplicate the group create, and let's get a very low res version of this billboard, and then let's put it into the display, and then let's merge these. So now we're gonna have something for display and something for render, and then later on we can split them by using the group that we created here. So this is going to create our copy to points. Obviously, again, we create our UVs, which is fine, because in here, if I blast either one of these, I should have a reasonable, oh, we didn't change the render to render to display. Make sure that they're unique. Okay, so we have two good UVs, one for viewport, one for rendering. Again, this shape I'm doing here is just to create a bit more like a pixelated look in the advertisements. You can use honeycomb or any shape you want, it's totally up to you, or like a different versions as well. They don't all have to be same. It's just a bit, it just looks a bit more interesting once you see it creates like a little Moyer effect, and when the camera is aligned, even in the viewport, I don't know if compression will help, but you can see, I guess, kind of creates a little Moyer effect. That's even more visible like this, I guess. So it's a bit more interesting when you render it. Kind of looks pixelated, looks a bit more retro. So let's run this again. So it's going to loop over our 32 unique shapes, as we can see it on the bottom left of my screen. It's going to wait a little bit more. Okay, and then since in the blast now we're going to have the grid and the points, so let's just, before we write out the proxies, we'll put a blast here, and I'm gonna say it's packed, so I need to unpack it here, I believe. Yeah, we can unpack it after the blast, so we have access to the groups. Okay, and then I want to keep, I want to remove the display, and then this is the one I want to bake. And then we can say to render. Well, I'll say keep render. And then on the other blast, let's say keep display. And then we don't need this anymore. Oh, actually, let's keep it. This is to proxy. And then copy paste. Now this is to display. Okay, as always, color coding is important. So let's bake these guys out once again, and then this was gonna work with $F, and it's gonna write out from 0 to 32. So render to disk. Okay, we have our new proxies. And now we have our displays. Okay, so now what we can do is that let's go back to our building, test, and we had our object merge. Let's rename this to in ads. Oh, ads, not ADVs. And I'm gonna pin this parameter window so I can drag and drop my to display advertisements in there. Okay, so now we can go back into our buildings, and we're gonna have our original building here, with the advertisements, and I'm gonna unpack now. I want to replace 7 of these primitives with my advertisements, but I think we made a mistake here. So because we want to preserve the ID, add ID, and when we unpacked, I think we didn't do that. Actually we did, we still have it. So do I have it, add ID? They're all same. They should not be all same. Oh no, we need from here. Sorry, that was my mistake. Because I want to have access to all of them. I only want to write out individual assets. So here we have all 32 of them unpacked, all good, easy to use in Houdini. So let's go back into building again. Here I have now 32 unique advertisement and then things to replace. So what we can do now is, one second. So now in order to copy these advertisements on top of these locations, let's create just points where it counts. So drop in an attribute wrangle. Let's say create points on prim center. It's a long name. Switch the wrangle to primitives and then type at point on self at position of the primitive, semicolon, and this is gonna create the points at the center of each primitive, centroid. That's like weighted, but we don't want to keep the primitives also, so we just want to keep the points. So we can say remove point 0, at prim, and we don't want to keep the points, so we'll say remove the primitives but keep the points, 1. Sorry, this is supposed to be prim num, not prim. Should have removed all of them. Okay, well, I made a mistake. Oh yes, it's not remove point, it's remove prim. Sorry. Okay, that, and this needs to be 1. Okay, so we have our centroid points now. So a simple copy to points should do the trick. I don't think we need the loop here since the amount is quite little. But actually we need to use the IDs, right? Yes, so we want to create a random, want it to be random, so let's do it properly. Okay, so let's create a for each loop. For each primitive, for each point actually, I want to bring in all of my ads, but sorry, I want to bring all of my points, copy to points, and remember I have 32 of these, right? So these are my, that's gonna be disconnect the first input, connect to the second one, and then connect to the ads. But now it's gonna pretty much copy all 32 of them on every point, so we're gonna have 7 times 32 advertisements. So we don't want that, because what we want is we want to create a little condition that removes what we don't want here. So in order for us to make this all random, we are going to create a random let's call it advertisement ID per point. So in here we can do this. Not this is on the primitive, sorry. So let's drop in another wrangle. So we're gonna write a tiny code, say random add ID. So we can say at integer at add ID. I want to have the same one as the one of these guys. Add ID, yes. Equals random at point num. No, I want position. Based on position, this should give me a random number, right? So let's go F. So it's going to give me some random value, which is what I want. But then I want to fit this value because I know the total number of my advertisements. So my total number, so the random value is from 0 to 1, but I want to fit this again from 0 to 32 was our number. We need to check the folder. Let's check our folder. Where's our object merge? As you guys remember, we had this little Python that we could point to a folder, and it just prints out how many textures we have. So we don't have to create this by hand. So if you want more, you just create more, download from the internet, and then it's automatically handled. So from 0 to 32, so it's 33 of them. Okay, so let's go back into the building test and say 33. Now this is still gonna return a float. We don't want that, so I can just say here, convert that to an integer, int, not int I, sorry, and that should give me something from 0 to 31. And then if it fits, this is completely based on points, position, since most of them are gonna be completely different. This should do the trick. So now I have an add ID. All I have to do is to match the processing ID number. I need to reset the cache. So I need to now just blast away that is not 10 from here, and it should do the trick. So we can say another wrangle. I'm gonna put a null here. I'm gonna say in ID. So let's bring this guy down, and let's say I select add. This just gives a bit more control. I mean, we could totally just create a new meta import, create a random ID based on the loop. As with many things, there are hundreds of ways to do things in Houdini. So I mean, right now I'm using an actual ID. Maybe later on I may have to, you know, what if the client said, in that building, I don't like this red advertisement, can we make it different? So I mean, that's an easy way to just follow it, because we can just go, oh, okay, I'm on building 15, and then we will know which billboard is corresponding to which ad ID and fetching which texture, as opposed to creating something completely random, which is going to be much harder to track. Okay, so here we need to basically create a little point expression just for visualization. We could totally do this with completely wrangle as well, but I think we should just bring in an integer here and say add ID, apply, accept. Okay, so we want to get the value from in ID. So with the point expression is as follows: point, double quote, we need to put the path to the object, which is in add. Where is it? In add, in add here. Oops. And close quote, and it's going to print us some more information on how we can use this. So what we need to fetch in is now, so basically the first object is returns the X component of 0.3 of the facet 1 surface node. So the first number after you see the address is the point number, but in this case ours always 0 because we are looping through. And then the next one is what attribute you want to fetch in. So that's add ID, which is a string, that's why in double quotes, and then it's the X component. Ours is also a float, so it's X. There's no YZ. It should return us a number, yes, which should match with this number, yes. And now we can use this number to remove unwanted primitives. This is almost like a switch node, but I think it's faster. So if I at add ID does not match my custom channel, remove prim on self at no double quote on self at the matching prim number, and remove the point as well. So now we have 7, but hey, that still looks a bit uniform. So what can we do? First of all, we can speed up this. I believe we shouldn't have any, but we are using the thing. Well, yeah, I mean, I don't think we need to spend more time on making this loop faster, because like using a compile, so which we will be using later on anyway. It's just because it's just we do this once. This is not a per frame task. So, however, like I said again, if I bring this guy here, they're all facing the same way. So maybe we should kind of create a bit more random orientation. So basically you can just drop an attribute randomize, which is very easy to use, just before your points, and we can say orient, set value, and that's direction or orientation. It's a 4 float. Okay, and but we don't want it completely random, I would say. We can't use it. Maybe I can use the Gaussian. This is a bit easier to use, I think. We need to find the correct value on this one. This is set. I think let's just change everything to 0. And one of these should start making them spin. I will find it now, because I usually use it. Right now I'm not doing it from the other side, so going a little bit off here from the plan. And the size are also same. Is this all the 7 unique ones? That's a bit suspicious here. I want to double check. They all look same. This is a bit strange, because I have quite many different ones here, and it's surprising that they all look at the same size. Okay, I'll have to investigate this. It's quite same. This is number 10. Let's fetch number 10. This is number 10. What about the other ones? Oh, because we are not running this on primitives, that was wrong. But my ID, no, that's actually correct, because my ID values are on my point attributes. So actually, yes, that was correct. So let's put that back onto the points. It's just that it shouldn't be always 10, and it's a bit, okay, we can cross-check that by, if you select your loop, you can turn on single pass. So this is ID 31, which is, if we go blast here, because I'm suspicious about the sizes, which is telling me something is not working. As you can see, all my ads are different sizes. So this is 31 as opposed to 10. But then when I, maybe they are not all same size, just visual. No, they're all same size. Okay, I need to figure this out. We're gonna create, okay, let's start with scale maybe, so we can give them a random scale. Actually, we need a P scale because our size is already correct. So let's go uniform. We can do this, and it's a single frame. So it's, why is it set to add value? It should give me random per point. Oh, because I don't have a C. Oh, okay, yes. It is creating the value, it's just not randomizing it. Add value, set value. Okay, we'll do this manually. Let's create another wrangle. Let's go set scale. scale. So well, this attribute randomize was using quite well, so I would like to actually just find out why it's not working right now, because I've used that in the past quite many times, so I must be doing something wrong, guys. So this is here, it's working, set value, add value, and I just need one, and it is working. So I must have just picked the wrong parameter, so it should be working now. Okay, so they are working at the moment. So let's pick up a good size. I would say this is okay-ish, not so big, not so small. So that's the randomize size. Let's create another one to randomize. Let's say randomize orientation. Orient. You can use normal as well in this one. And I think 0, 0, 0 here, 0 here. We need to create an up vector, something like this. This one is, this can be 0. Let's put this to 0. Let's go to the third one. I think this one should give us some more random orientation. You can say normalize. Okay. A bit, just to give it a bit more random. Let's put it to 0. Maybe, okay, let's put this to 180. Or 1, sorry, this is not angle. Okay, just to give it a bit more random orientation. Okay, so I think I want them a bit bigger. So let's go 3 maybe. Okay, so now I am gonna erase this one. We brought in the ads here, and we know that we have 2 of the remember, we made the proxy and the high-res version. So what we can do is that we can unpack before we copy, let's say, and then in here we can blast our high-res version. So we want to blast the render version. So in here we have a grid, and here we have just the very low-res versions. So now we have a low-res representation of our advertisement. They're quite big. We right now some of them are passing through the building. We're gonna push them away we can use the bounding boxes, but for now that's fine. So we also bake this out. So what I would like to do now is to do a little render to see how it looks. I'm not going to merge the building renders with the advertisements. I want to give them a separate, say them as a separate object, so this way it's a bit more easier to manage, so we can render them a bit separately, or just replace them easier in the future. Well, although we totally can even if we render them together, but for now I think it's a bit more clear way to work. So let's disconnect this guy here, and let's do our test render. I think we can bring in our building test, building advertise test. So I think we should rename this to building LookDev, and then probably this should just stay here, and then we should fetch this to another object called building. Let's create a new geometry, building advertisements. We can give some space here. Building advertisement, or ads for short, actually it's easier to manage. Let's do an object merge. So for this one, I'm just going to use it for rendering. So I just need to fetch in pretty much these points that has the ad ID and everything. So I think it's then we should probably put a null here, say advertisement points. So I should just bring them here in, and this is here. So we still need to copy our attributes. Oh, actually we don't, because we already baked this out, right? So we just need to load the proper one based on our add ID matching attribute, because this is what we want the instance back on. So if we go back to building ads, yes, we brought this here, and then we just want to make sure that's the correct one. Advertisement points, yes. So this is for display, this is to render the building before we bake in the textures. So out bake, and then go back into the advertisement node. So let's examine our points. So we have add ID. Okay, so basically we can create now a new string using the add ID that points out to our render nodes. So we did that before. Let's back into the ads. So basically this is the address we need to fetch. Because you might have a different file name, I'm just gonna actually get the full file name here. I'm gonna copy this and then go into the building ads. Now I'm gonna create an attribute wrangle. And paste this here. So what I want is to create an instance file attribute that is a string. So I go s at instance file equals printf, open parentheses, double quote, put the address in, double quote, and then I want to replace basically this number with the attribute itself. If I did it correct, it should have worked. Sprintf, I think it's sprintf, sorry, yes, typos, it was a sprintf. So now I have an instance file string attribute that is pointing to a location on a hard disk that I'm going to open now. That I already baked the Redshift instances, right? Which is fine. So these Redshift instances, this is the exact same workflow if you want to render with Mantra using BGOs. Okay, so this is now set instance paths. I guess here I have my random p scales as well. Here is I have my orient as well, so it should work exact same way. So I can put a null here, out, add render. So since it's a Redshift proxy, we need to drop in a Redshift proxy sub. Just leave it there. And then let's find our out network. I have this guy here. We can say add test. Let's select that we want to render this guy. Actually, you don't need that. I don't think this should work out of the box, but we can give it a go. And it didn't, because we're too close maybe. Let's zoom out. Okay, let's visualize our advertisements as well. So that should be fine. Let's try again. Actually, we can try here. LookDev camera. Oh, there's only showing one. That's where we did. No, that's only one camera. Okay, there's we made a mistake maybe. Here is. Oh, what is it not seeing? Okay, maybe I can try this one. Maybe this one is not good. Let's try building ads. Accept. I don't need any lights at the moment. These should be all emissive, and I don't see them. Okay, I think we need to activate instancing on the object itself, which is here. Redshift instance override instance file. I don't need to override it, but it should have worked. using common use point Redshift instances, Redshift point clouds. Let's try this one. Okay, we're not seeing it. Maybe it's the camera. We have the camera. Okay, let's go back. This, maybe it needs to be on here. Maybe we had the wrong flag. Let's try again. Now I see something, but they're dark. Okay, they are not fetching the textures, so that's what we need to figure out why. Let's go back here. Redshift instances. Oh, because they have unique shaders. I think that's why we need to overwrite instance file with process instance and instance file to inside. Instance Redshift. This was working. I'll have to check that with my other scene. But let me try a few more times. It looks like it's almost not fetching the correct textures. Let's dive back inside the ads, but I'm not going to record this part as I'm trying to debug, so I'm gonna pause the video now. Okay, so I found out what was not working. It was a bit something I actually missed. It was quite simple. So first of all, the paths were not set correctly, so because it was not finding the correct path, because we had after the for each it was loading everything, and then we were saying just get the prim num, and it always fetches the first one. It's always the first texture, which is 0, which is not correct. So what we need to do instead is that after, because for each of them that we're gonna write at the disk, first we blast them, right, just so we have one unique left. And then in this one, we then assign the material, relink the material. So now based on each frame, we have an updating texture name. Okay, well, sorry, again here, after the material name is changed, we need to get the because these are already recorded, right? So if I go here, they already have this changing based on which we already created here, texture name which we already created here, based on ID. So now if I check my material path after I have my unique object, and if I change every frame, I see that my value is changing, which is good. So here we can change the for each to blast one as well, just to make sure that we are calling the information from the one and only available node. So right now it's gonna write out a proper path out, and now our material is assigned. And the other thing that we were not doing properly was I think this was the only thing that we were outputting was add ID. So basically we were unpacking our object to get rid of the grid, but then we were also getting rid of the material override, which we cannot, because then it doesn't know which material to assign anymore. So let's bring back the attribute unpack. So here we have the blast. So in unpack now we want to output everything. So now if I do a middle mouse click here, I preserve the material override, I preserve the short material path and texture name in case I need it in the future. So this should now do the trick. So basically then you go to proxy and write these out, and this time our proxies will know which textures to fetch. Okay, so our textures are written out, and let's pull back to our advertisements. Hopefully this should now work once I hit render. So in the Redshift I have the building ads, which is this one, and if I add render to mplay, and now we have unique textures that are emissive, which is pretty cool. Okay, so now what we can do is to bring back our building, which is here. Okay, let's just make sure that this is okay. So let's maybe center this a little bit. Okay, so this should now give a bit more interesting result. So I'm gonna go drop in some quality settings just for the speed's sake. Brute force 2:64. Actually, I want to keep these settings to reach back after, so I'm just gonna duplicate this rope. Let's call this BuildingLookDev, and let's call this R&D. Okay, so now I want to run this. Let's just double check that this is still working. It's still working, and then let's load in our buildings to render as well. BuildingLookDev. I'm gonna turn off the global illumination for now, but I still want to load back my out lights, external light and environment light. Render template, let's see what comes out. We can also turn on the Redshift render info for more information as it prints it out. Okay, so our advertisements are working. Right now in this render we don't have the global illumination, so we don't see the office lights on, but you can see slight reflections. So what we can do then, now let's do a little maybe we can do irradiance cache and a brute force, because we're going to use this for baking, so we don't need to use brute force. We can, I mean, this depends on your quality settings, but I found out that with this many interior lights, if you go brute force and brute force and then more than 1-2 GI bounces, you really need to go really high for the brute force GI ray amount, which can be quite slow. So now I'm going to hit render, then I'm going to pause the view to see what we have in the end. So let's open the render view this time. We need to select our rope and we'll start calculating. I'll actually start slow, but I'm going to pause it anyway. It might take 5 minutes or so. Okay, so about the advertisements, because the intersections were really bothering me in between the last video and then now, so I kind of just scrapped that and then make it just now a little bit more elaborate. So just bear with me. So you go into your BuildingLookDev scene. That was the one that did this guy here that we where we do the LookDev in our buildings. And so after the unpack, I'm putting a convex hull. It just kind of gives me a convex hull as it says. And then convert it to VDB from polygons. Be careful with your value, because since these are big buildings, some by default is 0.1, and it might end up creating a lot of points, which is not, which might end up killing you using all your memory. And then kind of use the VDB reshape STF to just make it a bit bigger than what we need. So basically, it kind of creates a hull. I'll try to display that a bit better. A hull around our building, all right? So then just scatter points around the new shell, and we just use the we create the IDs, we create points, sorry, well, actually we don't need that anymore because we're scattering points. We don't need that anymore. Here I'm creating an integer ID at random ID. Okay, so every time these buildings will be, these points will be in different places, so it's going to create a different ID, because we create our IDs based on the position. So I'm just going to write this properly, and then adding the scale, adding the orientation, and then kind of this is what becomes. So if I let's bring this in here. Until this our building, so then we object merge that into our proxy node here, and then this is what we want to render as we discussed, and then kind of have a bit more elaborate solution. I guess we don't want any advertisements on the bottom, so we can probably just scatter along the uniform height, so we don't take the top 20%, I would say. So for that we can do a wop swap, point wop, get the relative bounding box. Okay, and then here we're gonna output, we can actually use the density for CD, but I don't think that would override anything, but let's keep it easier because that's a vector. We don't need a vector to create a weight map, right? So bind export, let's call it density, vector to float. We will only want to create a ramp based on our height value, so I'll put a ramp parameter. And then if I plug at the CD, it should give me a fall off, yes. And then we can play with it, but I don't, okay, we can actually connect it to CD, but I don't want the color attribute to go into the render instances because it might contaminate. I don't know actually by default if Redshift instancer fetches it. So we're gonna connect it to this density. After we can delete the density as well. In our scatters, let's enable attribute density attribute, and because the default is density, that's fine. So it's gonna distribute more on top than the bottom based on this color here. So if we go here, and let's maybe lock this. If you go outside. So we have more on the top than the bottom. So if you want more at the bottom, we can just, I think, slide this to the left, and then we'll have more on the bottom as well, but not very, very low. Okay, so let's keep this. I think we have some more room for size, or no, because last time in my advertisement, in my promotion video, I think I had too many advertising, so I'd like to actually bring that down if I could, to be fair. So let's leave it like this. Then the next thing we need to do is to bake out our textures and do our test renders. So in order to do a bake texture, we actually before that I was gonna show what so we were rendering. So let's go LookDev test, and then I guess we can copy paste this LookDev texture bake. But we'll have to do the texture bake through PDG because we need to change values. So it's kind of like a wedging, but I use the PDG to do that, so which is a bit easier. So that will be in the next video. So again, I'm gonna start the render and then pause it, and then just see what the result is. For this to work under the LookDev test, make sure you for speed's sake, I'm using irradiance cache for primary and brute force for secondary. If you get more noise, you increase these values, and then all this detailed information can be found in the Redshift documentation. So I'm going to save this scene now so it doesn't crash, because that's actually what happened last time. So I had to do the whole 40 minutes of file incrementation again. So the cool thing now is that if you change frame, because our file loaders are linked to our we're getting a really big scene here. We need to be careful with that. Okay. When we change frame, we should automatically load it should automatically update all the necessary updates for the advertisements and everything. But I think because some of the buildings were having a problem, like this one, we're having some random super big shapes, so we need to pay attention to that. This is coming from Boolean, and I think what we can do in this case is that something very simple. We can say if we can create a bounding box, really, and we can say points bounding something bigger than, I don't know, 100 meters, just remove it. Delete not selected. Let's should get rid of that. Okay, so our building is a lot bigger than that. Oh, that's actually pretty cool. So let's go 500. So let's go 1000, I suppose. 1000, 1000, 1000. And that would kind of clean that dirty geometry out. And then I think then we should do that here, because if the geometry is broken and if there is a geometry that goes far, like forever, in this case, if we select this guy here, and we're gonna get some really big numbers, and so the VDB is obviously failing because it's just gonna run out of memory. So that's actually a bit of a cheap cleaning, but it does the job, so we should be fine. So now the bounding box is reasonable. So what I want to show before it failed was we just have to change the frame. In a few seconds we get an update on our new assets, and then I can see that some of our advertising boards are really big, so we might have to this is based on your approach on how you want to make your city look like. So I would say, to my taste, they're a bit too big. We can play with those, but that's fine. So let's pick a building again. I think this other one is a bit more interesting to see. This one looks a bit big. So let's pick another one maybe. Okay, we can, this one looks a bit more futuristic, so we can do a test on this one. There's a little cavity here as well. So let's select our camera, record a new angle maybe, and hit render. Open render view. I was recording before, and render. So this is the irradiance cache being calculated. It's a bit fast, so it's a bit noisy at the moment. Our advertisings are showing, and as soon as the irradiance cache is finished, the brute force will kick in. But it uses the irradiance cache to do some calculation as well, so it's not so slow. Just waiting a bit more. Any second now. It's really noisy. I really need to increase the resolution on this one, but you guys get the idea. So that's, now we have some kind of already working building setup. So the next thing that I want to show is how to bake these buildings texture, so we don't calculate over and over when we render, because if one building takes 5 minutes, imagine 100 building, that's gonna take way too long for us to render our scene. So we want to obviously avoid that, and for that to work we need to bake all our textures into UV space, which we already prepared properly. So instead of calculating GI and reflections, it's just going to read them from a texture, which is just going to work a lot better and a lot faster. Because my render times were almost around 1 hour per frame in the footage that we see when the camera is panning up. And now after I baked them, they went down to literally like 10 minutes per frame with all the volumes and everything. So that's what we're going to do tomorrow. So we can use next video, so we can use our textures to PDG to bake our textures, and then prepare our shaders, new shaders that uses these textures for speeding up our renders. So as you guys can see, it's actually quite interesting already. We'll have to play with some settings in order to get some noise-free renders, but that's so far so good. So thank you for watching. See you in the next video.